Good afternoon, everyone. I hope all of you are doing well. So my name is Shakti Sindhu, and today I'm the host for this webinar today. So we are going to have a knowledgeable session related to WHO Technical Report Series 961 Annex 9 and also Supplement 8. So in this session, we will discuss about our key important features of this technical report series 961 and Annex 9 and Supplement 8. But before we start, please allow me to thank all of you to spare your valuable time with us. It's really our pleasure to have all of you with us today. During the session, we will discuss many things, many topics, and you may have some queries and questions in your mind. So, for your references, we have just shared a query sheet with you. Kindly check in your chat box. So, I would request all of you to please be attentive and keep all your queries in that sheet so that you may share all these things with us. We will take all your points in the question and answer round once we complete the session, and let's together make this session very interesting and very knowledgeable to all of us. Once again, thank you so much, and now we are going to start our session. I hope my screen is visible to all of you. So, in the next 1 hour, we will discuss many things related to WHO guideline. It is a very important guideline for basically to handle all temperature and time dependent products, pharmaceutical products, and so. This in this session we will discuss primarily the mapping part, basically because this WHO TRS 961 Annex 9 series is document is basically designed to provide guideline to handle basically TTRS means how to maintain the things starting from the import and warehouses and mapping and all. But there is an additional part. Basically, this is supplement 8, which works together with this TRS 961 and Annex 9 series to provide exact things to be done, particularly for thermal mapping. So our main focus will be slightly on WHO TRS 961 and Annex 9, but more focus will be on supplement 8. All right. Now, so what's on our map for today? Here, look at our agenda. So first, we will dive into. We will start with the fundamentals. What exactly the temperature? TRS, that is Technical Report Series 961 Annex 9 covers, and just as importantly, what it does not. All right. So when we discuss what it does not covers, so here supplement 8 come into picture, right? Next, we will dive into the core of the topic, that is thermal mapping itself. So we will discuss the objectives, the critical role of the protocols, the device means data loggers we use, and how to approach the analysis part. Then we will look at modern practices, which is not just about compliance, but it's about efficiency and data integrity using modern sensor analysis and digital record. Crucially, we will highlight the common pitfall. I'll share insight into frequent mistakes we see, and more importantly, provide practical fixes to help you avoid them. We will then chart a clear pathway to compliance in the final part with actionable checklist that you can take back and implement immediately. And finally, to make this practical as possible, we will touch upon some quick templates giving you the skeleton of a protocol, the essential of a report, and how to link everything to your kappa system. Now, additionally, what we have planned for you in the last part of the session, we will share some knowledge bundle with you that will include basically the summary sheet of WHO TRS 961 Annex 9 as well as supplement 8. Additionally, we will share some frequently asked questions, these related to this guideline, and it will be like short question and answer type. So you may find so many queries which may be in your mind, and that will be answered through a document, and we have tried to cover as many queries as possible in those knowledge bundle, frequently asked questions. And finally, we will have some multiple choice questions with answers and explanation. So this bundle will include everything which is mentioned in supplement 8 and Annex 9 series. So I feel, and we have tried to cover everything related to this WHO guideline. So I hope this session will be very knowledgeable, and it will help you out to enhance the understanding related to the topic. Now, coming back to technical reports series 961 Annex 9. So basically, allow me to give a brief introduction about this document. So it was issued by World Health Organization as Annex 9 to its technical report series. So there are some technical report series number 961, and in that Annex 9 is particularly designed named as Model Guidance for Storage and Transport of Time and Temperature Sensitive Pharmaceutical Products, TTSPP. So this is the nomenclature of the document Annex 9. Now, basically, what this document provide? So this provide a comprehensive framework for the safe storage and distribution of pharmaceutical products that are sensitive to time and temperature, such as, and what can be those products? It can be vaccines and other biologically active drugs. Now the question is what it covers, right? So it covers every guidance related to its importation, warehousing, storage building, temperature controlled storage, material handling, transport and delivery, labeling and stock management, general procedures and record keeping, environmental and quality management, personnel and training. So you can find that this guideline provides a variety of topics related to the TTSPP. Now, here there was some space available to define the temperature requirement. So here supplement 8 come into picture, right? So supplement 8 basically was designed to accompany Annex 9. So we used supplement 8 together with Annex 9. So I hope the basic covering of Annex 9 would be clear to all of you. Right now, core basically. As I said, that this document is basically to handle TTSPP, that is temperature, time and temperature sensitive pharmaceutical products. So this document is designed to give some guidance on the topic, as I mentioned earlier. Now, particularly in this document, the focus, or in this webinar, the more focus is basically on temperature controlled storage, right? So wherever now temperature is maintained, or any product is kept stored in any area, so here in this session we are going more focus on that particular part. So basically, Supplement 8 emphasizes the need for a robust system of controlled continuous monitoring and effective alarm, regular calibration of equipment, and of course, qualification of the storage area. Sorry. This is where thermal mapping plays a significant role. Mapping is basically primary tool to qualify any storage area. Basically what it does means, what is the outcome. So basically mapping ensures that particular area is suitable to store any TTSPP or not, right? So just right, yes. So it is important to know that the annexure is not act alone. So annexure 9 is not acting alone. So here we need supplement 8, as that supplement 8 part is focused on more on temperature mapping part. So here the importance of supplement 8 is there. Now, so whatever we will discuss, it is basically mixture of annexure 9 and supplement 8 together. Yes. Now, very important question is when to map any area, or we can say someone may ask why mapping is required or when mapping is required. So in the guideline, there are basically 4 case scenarios where we should have mapping. So first is basically in the very beginning part. Let's suppose we have constructed an area and we want to use that area to store our TTSPP. So as a qualification part, we need to first map that area to ensure that yes, this area is suitable for the mapping, for the storage of that products, right? So this is non-negotiable step, means we cannot avoid that. So essentially we must have our area mapped before we start using that area to store any product. Second, periodically, basically to demonstrate continual control, like we have mapped any area, now some time passes, and let's suppose we have close 2 years, 3 years. So continuously, based on the criticalness and the due time for the mapping, basically the space that was compliant 3 years ago, 1 year ago, 2 years ago, depending upon the time, may not be same as today, because the equipment we use inside the area may affect due to some aging reasons. Now the seals, whatever the seals were used, they may degrade, so there may be some leakages to the ambient conditions, so temperature may vary. The industry standard, basically what we are observing nowadays, this is frequently. This is very dynamic, and industry standards are upgrading on every approximately 3 to 5 years. So these are changing. So we, to cope up all those requirements, we require the mapping interval accordingly. So due to all these things, particularly if we talk about Annex-9 series, here the recommended mapping frequency is 3 years. It is important to understand. Now, next case arises when any significant change is being done in the structure. So structure, when I'm telling about structure, so it is basically the physical structure, the physical area where the product is stored. It is it may be warehouse, it may be anything, right? So if there is any significant change in the structure, in the physical construction, if there is any change in equipment, or if any HVAC system is upgraded or changed, if any AC is additionally introduced, if any means door is entry or exit gate is increased. So in such cases we require temperature mapping, and it is essential because all these examples are covered under changes in the facility. So after every changes in the facility, we require temperature mapping, because earlier mapping was as per the previous physical construction of the area. And finally, as a diagnostic tool. So if your routine monitoring record means, as we all know that you keep record all the facility with the data logger and other things. And once you feel that yes, during the monitoring we are observing that there are some certain variations you observe. So to verify the compliance, to verify whether the area is maintaining accordingly or not, so we require temperature mapping. So now comes to basically the objective of mapping study. Before you place a single sensor, means to record any temperature variation, you must be clear, crystal clear in your mind better what are your objective. A successful mapping study is not just about collecting data, it's about answering specific questions. Now, as we know that the storage area is basically consisting of airs, and in air there are always possibility of variation in temperature, because these are subjected to the non-uniformity of temperature, right? So the area near to the heating coil or any AC, there may be some different temperature, and as we go means away from the area, the temperature will definitely vary. So it provides the variation in the temperature. So due to this temperature variation, it becomes important to have a mapping study in place, right? Now this variation we study under thermal mapping. So basically what, and we call it as temperature distribution. So first we need to document, identify the temperature distribution. Also we need to identify hot spot and cold spot. So these are basically extreme conditions that any particular area which is showing highest temperature average is called as hot spot. Any location or area, not area, any particular location which is showing the minimum temperature, so that particular location is denoted as cold spot. So The objective is to document the temperature distribution and to locate the hot spot and cold spot. Second is to demonstrate the performance of area under empty and normally loaded conditions. So as we know that when any area is empty, so the overall volume, the volume where any air distribution is there is more. When we place some product inside the area, the effective volume becomes low. So in that case, temperature distribution differs. So that's why we require to study the temperature distribution in both empty and in loaded condition. Right? Next, to define no storage zone. So no storage zone means any zone or any location where the impact of external factors are more dominating, right? It can be near to the heating coil, it can be near to the AC, it can be near to the gate. So these locations, these positions are practically not suitable for the storing of any product. So through the mapping study, we also try to define the particular area, no, which is called as no storage zone. And finally, if needed, and it depends upon the basically type of the product we store, if needed, determine time to excursion during power loss. So generally we do power failure door opening. So we simulate the practical situation that in an area there may be some power outage, there may be some entry or exit. So in that case, the temperature distribution will differ. So during that temperature variation and means how much time the area or the AC or heater will take to maintain the required temperature in that area. So the mapping is also used to get that time, right? Generally we call it as recovery time. Now, coming to the protocol part, now here the most important part we must say comes in picture. Your mapping study is only good as your protocol. So if we say this, so the primary focus must be on the protocol. So if protocol is good, then our mapping will be good, right? What are the essential part of any mapping protocol? So it starts with approval and change control process. So we must define what will be the approval, what will be the scope and the rationale, means what will be the acceptance criteria, what will be the passing or fail criteria, and what will be changed, right? So if any change in the protocol, so that must be addressed through some change control. So we should have all these things included in the particular this approval part. Next is methodology. Now this is the how to section. So this must specify the type of data logger you will see, right? The layout or grid of their placement, how the logger will be placed in that particular area, and what will be the sampling area, sampling interval, and how often the reading will be taken. So all these things must be covered under methodology. Next is operational plan. This covers the logistics. What are the safety procedures? How we will control access to the area to prevent interference? how you will log events like door opening and anything, because when any door opening is there, so definitely the temperature distribution will disturb. So we must have a control in that. And what is the planned duration of the study? So all these things must be covered under operational plan. And finally, data and reporting. So whatever data will be recorded through the data logger used during mapping, and how the reporting will be there. So all these things must be a part of your protocol. I'm sure that you all are following the same. Now, Now comes the device which you use during mapping. So it is data logger. Based on the practical scenarios or requirements, we can use wired data logger or wireless data logger. But as per WHO guideline, there are some certain specification that must be followed. First, the programmable interval must be within 1 to 15 minutes, and the data logger must have sufficient memory to record the overall activity throughout the mapping duration. Next is the data logger we use. It must cover the range, the maximum range, that is from -30 to +60, because this is something, this range covers the entire type of storage areas. Next is the data logger must be calibrated. Here it is mentioned that NIST traceable 3-point calibration, because it is mentioned in the guidelines, so I have referred it. But it may be NABL traceable calibrated data logger as well, because NIST is related to the US. So in India, we can have NABL traceable calibrated data loggers. Right. Now, the accuracy should be equal or better than ±0.5 degrees Celsius. And the calibration must be annually. So this is specific requirement mentioned in the WHO TRS 961 supplement 8. Now, next will be the requirement of data handling through data logger. So it must comply 21 CFR Part 11 requirements wherever applicable. And finally, a simple but important rule: use only one type and model of logger per study to eliminate a variable or some other conditions. Also consider using separate logger to record a door opening event, as this provide crucial context during data analysis. Now, a storage area does not exist in a vacuum. So it consists of air, and as I said that due to many reasons, there will be temperature non-uniformity, and hence the temperature distribution across dimension will be different. So considering the overall volume, we should identify how many data logger must be placed, right? And what will be the location of the data logger where we need to place them. So particularly when we discuss about seasonal mapping, in summer mapping, in winter mapping, in rainy seasons, the hotspot and cold spot may vary. So they can be shifted in different seasons. A spot that is warmest in summer may perfectly fine in winter, right? For this reason, the best practice to map under both summer and winter seasons. That's why mapping is being done in different seasons to identify worst case scenario in respective seasons. In loading condition, as we mentioned earlier, you must map both empty and normally loaded states. This bracket the performance and proves the system that maintain temperature under full range of operational conditions. Uh, if you talk about operational cycles, the real world is basically dynamic. So weather changes. So accordingly, uh, we should have sufficient data how our storage area behave in different seasons. So that's why we use different type of mapping in seasons. And finally, sorry, and finally, document everything. Means whatever we observe during mapping, we should record. So let's suppose in any mapping study, some area is found where temperature variation is significant. So we should document it and we should take appropriate measure to identify the reasons and to control those phenomena which is causing this impact. Now, as I said that cold sport and hot sport shifts during the seasons. So in every season, hot sport and cold sport may vary. So it is very obvious. Mapping must be done in both empty and loaded condition in every seasons, because the behavior of the storage area will differ for both the conditions. And we should capture the operational cycles, door opening, power failures, and loaded conditions. So all these things must be covered in a mapping to have a broad uh, way of data that we may utilize and we may use to mitigate all possible risk of having any particular excursion or any particular non-compliance. Now, important part is to have ambient temperature and RH, or if we talk about only temperature, so ambient conditions must be recorded. So for that we should have ambient temperature in place, so that so that the data provided by the ambient temperature will show that the ambient temperature is like that and the storage area's temperature is like that. So it provides the overall picture of the temperature controlled conditions. Now, you have your protocol, you have your tools. Now it's time to execute. A smooth execution basically relies on the simple four-step process. First, brief. Communication is key basically. Before you begin, brief all relevant staff who are working in that particular premises that yes, mapping is being done. So you should avoid this. You should not open the door without reason. So we must communicate, and we must communicate the requirement to all the concerned persons. Set up logs to track access to the room and any power interruption. So if there is any power interruption, you should record so that you may have sufficient data. Next is to start. Now, get the technical detail right from the beginning. Ensures the clocks on all your loggers are synchronized. So, so why when we start mapping? So first we configure data logger. So every data logger is configured in a same temperature recording cycle. So for example, if 1 minute cycle is there, so all data logger will record the temperatures and temperature conditions on every 1 minute basis. If data logger are having 2 minute or 5 minute cycle, so every data logger will have the same sampling time. So we should follow this. Otherwise, what will happen? The temperature recording at particular time instance will be different for all the data loggers. Right. Finally, next is to collect. We have planned everything, we have executed everything. Now it's time to record the data. So the mapping data is recording for the entire duration, and that data is recorded in data loggers, and we use that data to perform analysis. Now, finally, it's analysis part. So we, based on the data we receive, we provide reports, and in the reports we have some analysis: hot spot, cold spot. The temperature may within the acceptance limit, may go beyond the acceptance limit. So whatever the proceeding, we will define based on the data we observe. So whatever deviation we observe, we must record it. And once we record it, we should take appropriate actions to control all these things. Now, coming back to the analysis part. So we have a set of data which we received from the data logger. Now we analyze that data. We compare that data with the acceptance limit defined in the protocol as per our requirement, means as per user requirement. Now, based on the data, we compute minimum, maximum, mean, or different other parts of the analysis. Identify hotspot and cold spot for particular sensor placement. Now, why hotspot and cold spots are important? So hotspot and cold spot are important because once we have information about any hotspot and cold spot, so these are the area which are having the maximum risk to exceed the basically the worst case. So we should focus to record the temperature reading for the area. Means we get hotspot and cold spot for any area. So our primary goal is to utilize that information by implementing a recording mechanism at those particular points. Right. Now, next is to connect the data logger to real world events, summarize the effect of door opening or HVAC cycle. So if any door opening or power failure is happening, so we should have the appropriate remediation to control these things, and we should take appropriate kappa. So these are the basically outcome of the mapping and further actionable things. The important part, common pitfall. Common pitfall means what are the major case scenarios where the mapping part is basically impacted due to some unawareness, or we can say some negligence or like that. So these are some common pitfall. We have area. Now we should have sufficient logger to be placed in particular area, and that sensor placement must cover the entire area. Right. Now, in case if we do not have sufficient data logger placed in that area, what will happen? We will not have sufficient detail about the temperature distribution of the area. So in that case, what should we do? We should follow the size of the area. We should consider the size of area. We should calculate the area, and accordingly we should place the sensors accordingly. So it becomes very critical to identify the number of logger to be placed. If we have this information with us, how many data logger will be placed, so this issue will not arise, and we fix this problem. Now, ignoring vertical gradation in high bay stores, what happens? As per guideline, if any particular area is having height, let's suppose 3.6 meters, so there may be three layers of sensor position: middle, high, and in between. But if the height of the area is more than 3.6 meters, then in that case, what will happen? We should have the sensor placement accordingly. In that case, we will have to increase the lower vertical direction. So earlier we were using three locations across the height, so we will have to increase the number of local location across the high area. So we may have, let's suppose, 0.2, 0.3 meter, then 1.8, 3.6, 5.4. So we will have four locations across the height, and those height must be approximately equal to each other to get the maximum, or to get the optimized data for the temperature distribution. So it becomes very important to understand this concept. Now, next is we are using uncalibrated data logger or mixed data logger type. Let's suppose we are using logtech data logger, we use Rotronic, and we use Testo 174H. So we are using mixed data logger, but although the accuracy may be same, but the specification is entirely different. So as we already earlier in this session, that we must have the same type of data logger during activity. It can be either Testo, it can be Logtech, it can be either Rotronic, whatever it may be. But only single type of logger, and preferably the same model must be there. If we are using same type of data logger, same specification will be there, and we will have more uniform data with us. It will eliminate the risk of having different data. Next is, during the mapping, we are taking sample interval more than 15 minutes. Now, what will happen? As per guideline TRS 961 Annexure 9 and Supplement 8, the recommended temperature interval lies from 1 minute to 15 minutes. Now, if we take temperature sampling time more than 15 minutes, so it will not as per the WHO guideline. So accordingly, this may create problems. So it is recommended to have temperature sampling time or RH sampling time between 1 minute to 15 minutes only. Skipping loaded or seasonal states. So there may be situation when we see that yes, we have already mapped our activity in summers, so it will act and it is perfectly fine. So we need not to take mapping in winters. We must have mapping for the area in both in all seasons, in winter, in summer, in rainy, and in both conditions, loaded and in empty condition, because the behavior of the temperature variation will different in the different loading conditions and different seasons. And finally, weak data integrity. This is one of the most critical part during the record keeping, as everything is in digital form. During the recording, uh, the data is not complying to part 11 controls. Means if there is any variation or manipulation of data, it's very critical. So to ensure the maximum compliance, we should always prefer data logger complying 21 CFR Part 11 requirements. So if we all these, so we may overcome the common problem during mapping. So based on our experience, we have some more cases. Let's suppose if a person is coming to map any activity, to map any area, so he must be aware about the protocol. So before he start the activity, the person must be trained on that particular protocol. So if it is possible to share the protocol with Urja, so please share protocol in advance with Urja, so that person may be ready with all the details mentioned in the protocol. So he may act accordingly. He may use the details like area name, sampling time, what will be the cycles, what will be the condition, loaded conditions or mapping or empty conditions. So all these things he will keep in mind before starting the activity. So if it is possible to share the protocols, please share it with Urja in advance. If it is not possible to share the executed protocol with Urja, so please try to provide all the common details which is mentioned in the report, or which are to be mentioned in the report with Urja, so that first person will be aware with all the details, and second, there will be minimum risk of having any correction in the reports. Additionally, one more challenges we face during mapping, that we place the data logger at the area, and during the routine operation that logger drops down from the position, or due to some other reasons, that data logger is not available at that place. So it directly impacts the data for the mapping. So you can you can provide directions or instruction to Urja team member to place the data logger in particular location, so that it may not drop down. You may also instruct the available persons who are working in that area to ensure that they keep an eye on the data loggers, that yes, that data logger is placed at that particular location or not, and if they found anything which is different to the original location, so they may report the issue, so that we may take the appropriate action on timely basis. So these are some common pitfalls and fixtures which may increase the mapping activity experience and everything. Now, coming back to the modern thermal mapping and monitoring system. So earlier we use other loggers. Now, as technology advances, now there are Bluetooth low energy Bluetooth data logger, which transmits the data in real time, right? So such data loggers are available in industry right now. So these are the future of the data logger based mapping. Next is basically the digital part, the use of digital system. When we have data, now that data is to be processed accordingly, and if we use manual provision, manual calculations in place, so there is always a risk. So if we use any digital system or automated system to process all those datas, it becomes more easy to have error free data. So we proudly say that we use urjakel software. We have a software which is capable to process data electronically. We only need to provide the data to the software, and it automatically calculate hotspot, cold spot, and other study which we need to take from the mapping. Now, advanced analysis, like basically, if we ask about advanced analytics, so it's not just hotspot and cold spot. It's go way beyond the things. Modern software can provide control charts to visualize stability over time. So time, basically time dependent temperature performance we can see. So if you see the urja reports, so you may see the time dependent temperature and RH performance of the area. So you will have chart. Once you scroll down, so you will get the exact temperature and RH values at any respective time. So our software is capable to provide those advanced analytics, so that it becomes easy for you to visualize the temperature distribution. And finally, to linking to routine monitoring, the most important step, the output of your mapping study, basically to identify, not only to identify the hotspot, cold spot, but something else as well. So you should directly use those area to record the temperature and RH condition in that particular areas, and you can use alarm system in place, so that it automatically intimate whenever any temperature and RH condition is going beyond the defined limit. So these are the things which we take as a result of the mapping. Now, acceptance criteria and reporting tips. It is important. Now, very common question: how to setting the acceptance criteria. So, if I should say, so base the criteria on the risk, or we can say set the acceptance criteria based on the product you store. Your acceptance criteria, your pass-fail rule, basically must be based on the labeled storage conditions for the product you store. And through risk assessment, you can identify, you can document the acceptance criteria for that particular area. Report with clarity, right? So don't just show a pass fail result. Means it is at urja part. So this report will present everything, including minimum, maximum, mean, and the temperature RH graph across the mapping cycle. Be thorough. The final report is an official record, and whenever any auditor comes, so first he go through the report to identify or to assess all the performance of your storage area. Now, the report is basically generated from urjakel software, is having everything like the identification of the data loggers. Based on that, the calibration certificate you can have. You will have all calibration certificates of data loggers in customer portal. Uh, so you can directly go through those calibration certificates accordingly. If any deviation is there, which with respect to the acceptance limit, so it will always be there in the report, and it will help you to take appropriate action. And finally, provide clear whatever are there. If any excursion is there, so there may be recommendation part in the mapping reports as well. Now, just to summarize everything, just have a quick checklist before you start. First, we should have a approved protocol with clear scope and roles, acceptance criteria, etc. We should have sufficient calibrated data loggers which will be used to map the area, and those data logger will be synchronized and will have sufficient space to record all these things. Then we should place all data logger in an appropriate location, in a appropriate location as per location chart, in across the height and the length. And finally, we should have document which complying the data integrity. So this is basically a quick checklist. So this was before the start of the activity, and this is after getting the report, or after getting the activity done. So after completing the mapping activity, you should download. We used to download the data. We process that data to have other analysis part, like identification of cold spot, hot spot, and temperature variation across the mapping time, mapping duration. Then drafting the reports with conclusion and any deviation if there. And finally, communicate sensor placement changes schedule for next mapping. Means it is basically, we can say that it can be concluded in due date of the mapping. Just for your reference, we are in the final part of the session. So whatever sources we use for preparation of this webinar, this is WHO TRS 961 Annex-9, which was published in 2011. We also used Supplement 8, which was published in 2015, and finally the 21 CFR Part 11. So thank you so much for your time and attention. I would now like to open the floor for any question you may have. Thank you so much. Hello, am I audible? Hello. Hello, am I audible, sir? Hello.
Yes, sir, you are audible.
Okay. Now I request all of you to please raise your concern. We have shared a query sheet with you. So kindly put your queries in that sheet, or you can directly ask your query here. We would we would we would be very we would be very happy to answer all your queries, sir. One more thing, whatever query you may observe, so we have a provision in place. Please fill all your query in the sheet. This sheet will be used to provide you the most effective and most appropriate response to your queries. So it is hardly request for all of you to mention your queries in the query sheet. Hello. Kindly raise your query based on the webinar provided to you. It will be very helpful to understand the feedback provided by you, so that we may make our content or presentation effective for the next webinar we are planning to host. So it is request to all of you to share your concerns so that we may address here. You can directly raise your queries to by just putting your mic unmute. It will be our honor to respond your query. Any query? All right. So we are now concluding this session. Uh, for your references, we will share knowledge bundle with you on your email ID, which will include the summarize sheet for WHO guideline lecture 9 and supplement 8. We will also share some FAQ on those guidelines. We will have document designed for quick recap as MCQ questions. It will be very helpful for you, for your team, to understand these guidelines, and you can utilize those resources to prepare your literature, particularly on this topic. So we will try to have such sessions in future as well, and we will try to improve our presentation. We will try to improve our content so that it will be very knowledgeable to all of you and for us as well. Thank you so much. With these words, I conclude this session. Thank you very much.